Okay.
Is this a difference of squares?
243x to the fourth minus 3t to the fourth. So we have two terms, so we want to start by looking for a GCF. Is there a GCF between these?
3.
Probably 3.
Maybe 3. Let's check.
Yeah, because 3 goes into 24.
Yeah, 81 times.
Perfect. So this is now 3. Remember to keep that 3 out in front. And then 81x to the fourth minus t to the fourth. Now, if we didn't take that GCF out, this would not be a difference of squares because 3 is not a square, 243 is not a square. So you have to, it's really more important on these to take out the GCF than it is on the AC method. So now that we have that GCF taken out, we can see that it is a difference of squares. So we need to break down our terms and then it'll go into that F plus L, F minus L. So when we do our breakdown, we only have 2 things. When we have cubes, we have 3 things. So on that first term, 81x to the fourth, what times itself would give me that?
9x squared, 9x.
Yes, 9x squared, 9x squared. So that's what's going in for F. And then what times itself would give me t to the fourth?
T squared, T squared.
Perfect. So that's what's going in for L. So when I factor this, I'm going to remember to keep my 3 out front. And then one parenthesis will be 9x squared plus t squared. The other parenthesis will be 9x squared minus t squared. Now here's what I was telling you last time we looked at the AC method. I said you have to watch out for one of these to still be factorable. See how this guy is still difference of squares?
Yes.
You do it again?
Yes. So we're going to factor this one again. That's another difference of squares. So when we do that, we're going to keep our 3 from our original GCF. We're going to keep 9x squared plus t squared because that one doesn't fit any of our patterns. And then we're going to break down the 9x squared minus t squared into a difference of squares. So 9x squared would break into, yes, and then t squared times t. So we'll have 2 more parentheses out of that one. What will those be?
3x plus t.
And 3x minus t. Perfect.
How come we didn't do that with 9x squared plus t squared?
Because our 3 formulas that we have are difference of squares, sum of cubes, difference of cubes. And this one is a sum of cubes. Or sum of squares, rather. Backtrack. So we don't have a formula for that. Difference of squares we do, sum of squares we don't.
I'm confused, but okay.
Okay, difference means we're subtracting.
Well, I know that, but like it makes sense because 5 plus L and 5 minus L, and you have the addition and subtraction.
Right, but when I multiply, when I FOIL this out, when I do a plus times a minus, I'm going to get a minus.
You don't want
You can't, so you can't have a plus at the end.
Okay.
Does that make better sense?
No, but I think
Okay.
I know what you mean.
Like when I
Because
FOIL
there's a
this out,
squared on the, you had to do it because there's squared on the last one.
and a subtraction. When I FOIL this out, I'll have 9x squared, and then minus 3xt plus 3xt. Those two cancel out. And then t times negative t would be negative t squared. So in this pattern, I'm always going to have this term squared subtracting this term squared. It's never going to be adding, so that one can't work.
Okay,
It has to be some difference.
that makes sense now.
Okay.
Thank you.
Then we have the trinomial square. This is a pattern that if you recognize it, it will save you time. It's going to be a trinomial that can be factored into a binomial squared. And we saw those that we did by the AC method, but we didn't learn the pattern. So it's asking, is this a trinomial square? So what we'll do is we'll just factor it by the AC method, and then we'll say it's a trinomial square if it can go into something that's squared like that. So we'll just factor it. Starting with, is there a GCF?
No.
Yes. What? Wait, no.
4
No.
can't divide by 3.
Just kidding.
Uh-huh.
I'm sorry. I was thinking like
That-
factors
yeah,
of 12.
right. That happens a lot. Like these two can go by 3, these two can go by 4, but there isn't one. So then remember, by the AC method, we're going to take this first thing times this third thing, try and add up to this middle thing. So 9x squared times 4, 36x squared, and we're trying to add up to
6 and 6.
positive 12x. You see where we're headed here? 6x times 6x. Notice that that is the same, like we saw that the other day when we had 12x and 12x on our other notes. When those two numbers are the same, most likely it's going to be a trinomial square, but we'll go ahead and finish it up. So remember, we replace that 12x with 6x plus 6x. So we'll have 9x squared plus 6x plus 6x plus 4. And then we factor by grouping. So we group these two together. What can come out?
3x.
Perfect. So we'll have 3x times
2.
3x plus 2. Okay. And then we look in our second group. What can come out of there? 2. So we'll have plus 2 times 3x plus 2.
And you could just do 3x plus 2 squared, right?
Right. So then we have our common parenthesis, which will be 3x plus 2 times our leftovers, 3x plus 2. Whoops, went off the screen. So I can rewrite that as 3x plus 2 squared. So is it a trinomial square?
Well, maybe, yeah.
Yes.
Yes, because it ends up being something squared, a parenthesis squared.
I like it.
Yay.
And it was nice.
Are we
Oh, hi, I'm still on
Bye,
screen.